definition. Okay, the PC tag is assigned to an EPG when it is created by the APIC. So whenever you are creating a EPG, one unique ID is assigned to that EPG. Okay, and that ID is known as basically what? PC tag, policy control tag. So let's suppose here we have a app EPG, here we have a web EPG. I need a contract. Okay, so when this create, let's say 10101 ID created. When you create this, let's say 10102 ID created. Okay, so internally on the epic, when you create the contract and when you apply the contract between these two EPG, so internally it will be applied between 101 and 10102. Getting my point? Internally on the controller, it applied on these PC tag. Getting my point? Any confusion here with respect to the PC tag?
So far, okay.
No. So the PC tag is assigned to EPG when it is created by the APIC and used when the contract rule is applied to a packet on the leaf. Okay. The security rules that use the PC tag and that are created from the contract on the leaf switches are called the zoning rule. Zoning rule. So what is zoning rule? The security rules that use the PC tag that are created from the contract. Okay. See, we have app EPG, we have web EPG. 10101, 10102. This is the PC tag of EPG. But when you create a contract between them, okay, there will be one zoning rule is also created. What is that zoning rule? In that zoning rule, it will be like this way. What are the things allowed between these two? Okay, that zoning rule has the following parameter: source EPG, destination EPG. Okay, now if you remember, right, when you are creating a contract, you are defining that thing, who is the provider and who is the consumer. So you are telling that thing basically who is the source and who is the destination. Getting my point? Getting my point? Then on the contract, you are defining the filter. Under that filter, you are defining, okay, which protocols are allowed. Then you are defining the scope of the contract, like you are going to communicate under the same VRF, you are going to communicate under the same tenant, or you are going to communicate under the different tenants. And then you are defining the action, the traffic is allowed or not. Okay. Now, first three parameters, source, destination tag, and the filter, are the core rule that define what kind of traffic from EPG to which EPG should use this rule. Okay. Now, whenever we are creating a contract, in that contract we are defining source, destination, and filter. Source and destination will be defined by who is provider, who is consumer. Okay. Now, the fourth parameter, scope, is defined in which VRF this should be applied. In which VRF, meaning is what? See, EPG associated with the BD and BD associated with the VRF. If there are multiple EPGs, let's say web, it can be associated with the same VD, or maybe it can be associated with another VD or another VRF. That is also possible. Okay. Now, so in that situation, it is important because the PC tag is unique only within the VRF. Okay. The following is the PC tag types and its range. 1 to 15, it is system reserved. 1 to allow traffic such as one destination to ACI switch, CPU, implicity. 14 PC tag for the shared services, which we have used yesterday. 15 is for L3 out when we are defining subnet 0.0.0.0. Global PC tag start from 16 to this particular range. Local PC tag from this. What is global PC tag? This PC tag is a unique across VRF, and that is used for the shared services or the routing. Local PC tag, this PC tag is uniquely within the VRF, and the default PC tag for internal EPG and the L3 outing. So if you see here on the leaf, they're writing one command, show joining rule scope. This is what VRF scope ID. VRF scope ID. From where I can get this value? Pre-sales VRF. This is my scope ID. Getting my point? So if you click on the different VRF, this ID will be changed. Okay. There is one more option to see all the things in one window. Where is that one? This one. You are under the sales tenant. Under the sales tenant operational resource ID. So here, if you see, these are what my EPG, and the scope ID basically defining that thing, the VRF. Getting my point? Let's verify this thing. Yesterday, I have created this sales tenant. Okay. Under this sales tenant, I have these two VRF. Okay, exchange VRF. This is the scope ID of exchange VRF, pre-sales VRF, and this is ID of pre-sales VRF. Okay. Yesterday, I have created one EPG also, exchange EPG. And I told you that thing, exchange EPG is like this way. Exchange EPG associated with exchange BD and exchange BD associated with exchange VRF. Getting my point? So I can say that thing, this particular EPG associated with the exchange VRF, right or wrong? Right or wrong, guys? This thing is clear? Now, let's see that thing. I'm under the exchange EPG and you can see here my PC tag value. Okay. So let me write like this way. Exchange EPG, PC tag value is 49155. Exchange VRF, let's say that thing. Exchange VRF is 2424832. Okay. So this associated here. Now, if I verify that thing, click on the sales tenant, operational resource ID. Clear my point? Yes, guys?
Oh, yes.
Okay. Okay. So if you want to find out any, let's say, EPG ID, any VRF ID, you can just get from here. Operational resource ID, we have the bridge domain ID. VRF, yeah.
Sorry, I muted everyone.
Okay. Cool. No issues. Where we are. Yeah. So if you want to find out any resource ID, any PC tag, so directly you go to the tenant. That is the easiest way. Go to the tenant, operational resource ID. Then you can click on bridge domain. You can click on the VRF. You can click on the EPGs. Okay. Now, so here, if you put show joining rule scope and that VRF ID, it will tell you that thing like, okay, which VRF, so that particular VRF having how many EPGs and what kind of contract rules are applied there or not, permit, deny, that kind of stuff. Internally, it is creating the rule ID. It created automatically. What is the source EPG? Source EPG ID. Okay. Let's verify that thing also. In this EPG, have I applied any contract? Yes, one contract is applied. Okay. So what I will do 192.168.10.7t. I'm able to access, yes. This is my leaf. show joining rule, scope, and we need the scope ID. So operational resource ID, exchange VRF, (2424.832). Okay, so let's see. In this, now it's clear. Under this, we have defined one rule, define one contract. Okay, so permit. Source EPG, destination EPG. Destination here it is showing what? 15. Okay, and 15 is reserved for what? L3 out. Getting my point? Getting my point?
Yeah.
And 49155. If I go to 49155 belonging to what? Exchange EPG. Getting my point? So when you are creating the contract now, internally basically it is creating the access control list like this way. Okay. Filter ID, I haven't defined, like I use the default common basically there. Okay. The scope, this is the VRF ID. Exchange EPG associated with what? 224.832. 224.832. Right, guys? Any confusion?
Good on my side.
Okay. So my point is, whenever you are creating a contract, internally it is creating certain access control list. Fine. And if you have multiple contracts, so there will be multiple internal ACLs will be there. And if the number of ACLs are more, then they will consume my CPU utilization, my memory utilization, right? So what is the solution for that? We will also discuss that one. But with respect to the PC tag, this is clear or not? PC tag. So
Yeah.
whenever you are creating any EPG, any VD, any VRF, internally one unique ID for with respect to that VRF, VD and EPG will be created, and that is known as what? PC tag or policy tag. So here they are writing one more command, show joining filter ID 18. So in my case, if I have to run that command, so I will write what? filter ID. Here we have default one. The rest of the things I have already discussed, like EPG and all these things. We already discussed. Now, policy TCAM exhaustion. Now, when you have multiple contracts, then multiple entries will be there and it consume more memory utilization, more CPU utilization. To avoid that particular situation, we have few solutions. What solution we have? First solution is policy control enforcement in the VRF set to the unforced. Now, what is the meaning of this? Let's suppose you have app EPG, web EPG, and DB EPG. We have these endpoints. So if we want communication between them, right, we need a contract, correct? So my requirement is all these endpoints should communicate. Okay, all these endpoints should be communicate. So what I have to do? Same contract I will provide as well as consume. Same contract provide and consume. Same contract provide and consume. Getting my point? Because if you want to make a communication between them, this will be provider, this will be the consumer. But if web to app communication I have to allow, I have to make a provider as well as the consumer. Getting my point? Getting my point, guys? So in this situation, multiple entries will be created. And why we need a contract here? Because under the VRF, there is one option, policy enforcement control, which is by default set enforced. Enforced meaning is you need a contract between the two different EPG. If I set is unenforced, then we don't require that contract. Okay, but we have to choose that option only in that case when we need the full communication. Getting my point, guys? Where is that option? Exchange VRF policy. See this option, enforced control, policy control enforcement preference enforced. Enforced meaning is if you want to communicate under the two different EPG, you need a contract. If I put that thing unenforced, so whatever EPG are associated with that particular VRF, those EPG don't require any contract. Getting my point? This option is clear or not?
Clear to me.
Now, then second option, contract with VZNE. Okay, let's firstly discuss this preferred group. What is that preferred group? Now, same example. I have three EPG. 1, 2, 3. EPG 1 and 2 communicate without any issue. So what I will do, I will put those two EPG under a preferred group. If the EPG belonging to the preferred group, they don't require any contract. But if they want to communicate to any another EPG, then we need a contract. Getting my point? Clear this. Force then preferred. It's clear or not? And at that time, when you want to allow communication in all the EPG of a particular VRF, preferred group, but not in all. Okay. These two options are clear or not? Is VZ
Rakesh, I'm losing you. I don't know whether it's me alone.
I thought it was me.
Hello, Rakesh?
just a second, guys.
Hello, Rakesh?
Okay. Let me just change my service provider then. I'm audible now, guys.
Yes.
Okay. So currently I have discussed two options. First is VRF policy control enforcement. The default option is enforced and unenforced. You can select. Second option, I choose the option preferred group. Now, let's take, we have this option, app EPG, web EPG, DB EPG. They can be associated with the same BD, no issues. But they are associated with the VRF1. If it is enforced, which is by default, need contract in different EPG communication. If you select this option, no need of contract between EPG communication under same VRF. Getting my point? This option is clear, guys. Nicholas, Sam, Lordwin.
That's clear so far.
Good.
Second option is preferred group. Preferred group, like when we need the communication in, let's say, app EPG we have, web EPG we have, DB EPG we have. So preferred group is what? You can create a preferred group and you can put multiple EPGs there. So there is no contract needed here within the preferred group. But if you are going to communicate to another EPG, then you need a contract. This is the preferred. So you can include the EPG under the preferred group. No contract needed. If you want to go outside, then the contract is needed. Okay. Under the VRF1, you can enable it. Preferred group, you want to enable or disable. Under the EPG, you just tell include or exclude. That's it. Then we have VZNE. Okay. So VZNE is what? Let's take that same example. I have app, web, and DBPG. I want the communication between them. So I have to create multiple contracts. Multiple contract meaning is that same contract I have to provide, consume for full communication. Okay. I can define that thing like, okay, I can define one VZNE. Okay. In that VZNE, I can define multiple EPGs. So it can be like that way. One provider, multiple consumer, or multiple providers, one consumer. Okay. So in this scenario, let's see. VZNE use case. So under this VZNE, I have multiple EPGs. Those are what? Consumer. And one EPG is a provider. Okay. Or one EPG can be provider or multiple providers can be there. One EPG will be consumer and multiple providers can be there. Okay. So same contract will be creating what? One single entries for multiple EPGs. So where is that option? Under your VRF, you are getting the EPG and let's say, let me show you that thing under this EPG collection for the VRF. So here what you can see. You can provide which contract? Okay, consumer and provider. If you want to make it as a preferred group member, you can do that thing. Like this. Based on that, we have one activity discovery number 8. Okay, this discovery you have to do it very carefully. Carefully in the sense, when you open the document now, so these numbers can be changed for everyone. Getting my point? Just focus on what EPG they are talking on, and you have to take the output with respect to that particular number. Getting my point? For example, like loadwin, when login there, if we see these information, those information can be changed for loadwin, Nicholas, Sam, all of you. Okay. So you have to check the IDs like this way: pre-sales, what ID you have, and based on that you have to complete this lab activity. Okay, so there by default in this there is no configuration, just they are going to show you that thing how you can get the information from those PC tag values. Okay, for example, like they are running that command. Okay, complete this discovery number 8. And let me know.
Okay. So we can start the lab?
Yeah, start the lab. It's working, Nicholas, now. Okay, maybe there is some issue with your internet, maybe.
Been facing the same issue.
Yeah, yeah. Yes, I can see your screen. I told you that thing. Mm-hmm. Mm-hmm. Which step? Okay. Okay. Hmm. Okay. Just check this thing. This one na first one this 24. Okay. Just go ahead. Yeah, I am able to see. VRF. Which VRF? Which VRF? Pre-sales VRF. But they are checking there, I think so, with the that exchange VRF. Now check this thing. Like, okay, this go to your there. Go to your Epic first. Go to Epic. Just minimize this CLI. Yes, yes. Okay. Click on the VRF. Click on the VRF. Pre-sales VRF. Okay. Okay. Just click on the EPG. Click on the EPGs. Okay. The EPG ID is this. No, 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 no. This EPG belongs to exchange VRF. Getting my point. Above two, like app and DB EPG, they are belonging to the pre-sales. Again, again, click on the VRF. Again, click on the VRF. Check the ID. Pre-sales VRF 100 and last 910, right? Now click on the EPG. Under this 910, app and app and DB EPGs are connected. App and DB, yes. Okay, so that's why I told you you have to map the ID carefully. Yeah, sure. Guys, I will be joining in 2 minutes. Guys, I'm back. Next thing I'm going to discuss VMM integration, firewall integration, and PBR, policy based routing. Okay. This particular thing you have already done into your last week, DCACI. I'm going to repeat it. And on the same scenario, I will do the firewall integration, ASAV integration, and then we will discuss about the PBR, policy based routing. So first thing is, let's suppose this is my ESXi server. In this, I have the vCenter also. Okay. I have few virtual machine there, CSR1, CSR2. Okay. So firstly, I'm going to do the VMM integration. Okay. JCI VMM integration. And here we are going to discuss about VMware. Okay. So how we can integrate that? These CSR1 and CSR2, these are my virtual machine. Okay. Now, point number one, or you can say physical construct. Point number one, you have to create a VLAN pool, and the VLAN pool allocation mode should be dynamic. Point number two, domain. In the domain, you have to create the VMM domain. Okay. In the VMM domain, we will integrate vCenter with Epic. If integration successful, it create a distributed switch on vCenter. Okay. Here it will create a distributed switch. Point number three, you have to create AAEP, associate VMM domain. Point number four, interface policies. Point number five, same interface policy group, interface profile, and then switch profile. So where is the change? The change is here only, and here. Getting my point? Take the screenshot of this. Done.
Screenshot taken.
What you will do after this? Next point. Log into vCenter and add host to DVS. Okay, we have to add the host here so that we are defining that thing which host VM we want to connect here. Okay, then logical construct. So same way tenant VRF BD application profile. I will create EPG. Here I will create two EPG, app EPG and web EPG. Okay. Next point. We can connect VM to port group. But right now there is no port group. So when we associate VMM domain to EPG, it will create port group on DVS. Getting my point? Any confusion? So here will be port group. Here will be web port group. So I will connect like this way, and we need a contract between them. Getting my point? Take the screenshot. Clear, guys? Screenshot done, guys?
Yeah.
So firstly, I'm going to show you this VMM integration, and after that, I will discuss the firewall integration and I will do that part. Okay. So this lab you have already done in your last course, so you can recall the things. So whatever configuration I have done previously, I'm just removing that one so that everything will be fresh. Okay. So let's do step by step. Here I have HTTPS. Let me log into my vCenter. Just give me a second. Okay. So right now I have deleted all the configuration from the vCenter. There is no distributed switch. I have all these virtual machines. Fabric is completely new. Okay. Now, so first step, you have to create a VLAN pool. Allocation mode dynamic. Let's say 252, 350. Allocation mode dynamic. Then VMM integration. You have to create a VMM domain under the virtual networking, VMM domain, VMware. So let's say VMM DVS. It is a virtual distributed switch. Associate the VLAN pool. Then you have to associate the credentials. So let's say cred, username, password. Currently, I am putting a wrong password. Okay. I will tell you if the password is wrong, what will be the issue. Then you have to give the vCenter details. Data center name. Data center name is case sensitive base and associate your credential policy. You can select CDP or LLDP based on your requirement. Submit. After this, my controller should be online. I have put the correct password. Cisco 8123, right? That's why it is showing. Otherwise, if your password is wrong now, here you will get unknown. Okay. Now, it is showing controller is online. That means integration is successful. And if the integration is successful, automatically on my vCenter, one distributed switch will be created. Okay. Now, point number 3, we have to create a AAEP. Associate your domain. Then create the policies. After that, we have to create the policy group. After this, we have to create an interface profile. Port number 17. And associate your policy group. Then switch profile. Associate with the interface. This will create what? My physical construct. Point number 2, I have told you, you have to associate host to the distributed switch. New host, select host, okay. Select the uplink. Next. Done. After that, what you have to do, you have to create a domain. Sorry, you have to create a tenant. Let's say sales. In the sales, let's say VRF1, BD1. Inside the BD, I'm putting two subnets, 75.0.0.254/8, private to VRF only, 85.0.0.254/8. Then application profile, I'm putting here two EPG, app EPG. EPG must be associated with the BD and web EPG. EPG must be associated with the BD. Then now associate the VMM domain. So it will create what? The port group on the DVS. My port groups are ready. Then let's map the VM. I'm putting CSR1 under the app EPG. CSR2 under the web EPG. Okay. Let's start that one. The VMs are booting right now. I need a contract also. 50 interface gig 1 IP address 75.0.1. No shit. Do show IP route. Do show run. Okay. On the CSR1, if I try to ping 75.0.254, it's pinging. That means this VM gets the connectivity with my ACI fabric. Clear or not? Ping. Okay. Both the virtual machines are able to send the traffic to the ACI fabric, right? But if I try to ping each other, they will not communicate. Why? Because they need a contract. Clear, guys, till now? Any question? If I make a contract between them, they will communicate. Clear, Sam? Nicholas? Lordwin?
Clear, Mary.
Yeah. Now, let's suppose this is the first condition, like, okay, if I make the contract, it will work. Now, make it like this way. What I want a firewall here. Okay. And currently my firewall is ASAV, virtual firewall. Okay. I want when the CSR1 and CSR2, they are sending the traffic should go via my firewall. Okay. Currently, what is the scenario? Under my BD1, I have put 75.0.0.254, 85.0.0.254. 75.0.0.1 is here. 85.0.0.21 is there. I want to connect my firewall like this way. Okay. ASA firewall will work on the zones. Okay, inside outside zone. So I'm treating CSR1, which belongs to, let's say, app EPG. This belongs to web EPG. I'm treating it 0 by 1, and this is gig 0 by 0. On this ASA V, there are 10 interfaces. Network 2 will be internally gig 0 by HTTPS, okay, for HTTPS, for HTTP. Then this traffic will be redirected to my firewall and then go through that. If any other traffic is going, let's say ICMP traffic will go via the normal contract. Getting my point? Getting this thing? Clear, guys? This is known as what? Policy based redirection, PBR. Any confusion in this particular one?
On my side.
Cool. So after that, we have to do this lab activity. Okay. So we will do one thing. We will take a lunch break now. Okay. And then after the lunch break, we will do the lab activity because this lab will take like almost 1 hour. What do you say? Yes, guys?
That's okay with me.
Cool then. We'll meet after the lunch break, guys.